All right, we got a few questions here. We are still talking about arc length and area of a sector, but these questions look a little bit different. They say, find the area of the shaded region. Now, does this area of the shaded region include only the crust of the pizza? Not really. Okay, this is not just the crust. We're not talking about our arc length here. Does this area include the entire pizza slice?
No.
Also no, so we're not talking about using just the area of a sector. How could we talk about just this shaded region? How could we kind of chop some stuff up to figure out what that region is? Does anybody have any intuition how we're gonna do this?
I don't know.
Oh,
Pythagorean theorem.
Pythagorean theorem is not super far off, to be honest. He was trolling.
Yeah.
Same.
Okay, so think about this. If we do the whole circle, is that too much or too little?
Too much.
That's too much, alright? If we do the whole quarter of the circle, is that too much or too little?
Too much.
Too much. So what we need to do is take that, but it's too much, and we need to use a subtraction to take away whatever is too much. So the way we're gonna do this is we're gonna start with the circle, right? And then we're gonna try to figure out what is just the pizza slice. And then our goal is gonna be take that pizza slice and subtract the triangle. If we take this pizza slice like this, which should be all of that area, and then we subtract, oh, that's a very big eraser, and then we subtract the triangle, that is exactly the region that we want. So what we're gonna do here is basically the exact same question as yesterday, minus the triangle. So let's see how that looks, okay? Well, what we did yesterday was our area of a sector, area equals 1/2 r squared theta. Okay, what is the r? What's the r for this question? 8. And what is the theta for this question? 90, but we have to use radians? Pi halves. Type that in the calculator. All right. 1/2 times 8 squared times pi divided by 2. All right, we're in business. I got it. That the area is 50.265. You get that?
Yeah.
So remember, that area is too big. That area is the whole quarter of the circle. But what we want, eraser, is only that weird portion there that is on the outside of that triangle. So next, what we want to figure out, this is the area of the sector. What we now find out next is what is the area of the triangle. Triangle spelling. What is the area of this triangle? Does anybody know the formula for the area of a triangle? Ooh, area equals 1/2 base times height. Now that might sound super complicated, but for our equation here, the base is the radius, right? Because that's the base. So it's going to be and what is the height the radius again. Will you make sure to lock that up for me? Perfect, thank you. So, that's the area of the triangle.
How is it the radius?
Because we're going straight from the middle of the circle to the outside, well, that takes you the radius to get from the middle to the outside, 8, and that takes you 8 to get from the middle to the outside.
Okay.
So the area of our triangle will be 1/2 base times height. Well, base and height are the same thing. It's 8 and 8, and 1/2, right? That's gonna be
32.
sweet. Well, now, in order to figure out what the area of the dark region is, we want to take the whole area of a sector and the area of a triangle, and we want to subtract the triangle from the sector. So now we're gonna do 50.265, whatever, minus 32. And the answer for this shaded region should be 18.265.
Beautiful. Also amazing. No.
So, before we move on, because if you're thinking, whoa, Mr. Gar, that wasn't really hard, but it was kind of weird. What we figured out is that our triangle has the base and the height of radius, whatever that radius
It's
is.
a little bit.
And so if we look at these two formulas, this one is 1/2 r squared theta, and this one is 1/2 r squared. Because it's r for the base and r for the height. So, if you want to do this all in one fell swoop, instead of doing it as its own area and its own area and then subtract them, you could use the formula. I don't know if I'd recommend this or not, it's up to whether you want, that the area of this little small sliver thing here would be 1/2 r squared theta minus 1/2 r squared.
Why didn't they show us that before you did all that?
Because he had to show us both ways.
You know,
You always do the easiest way last.
it's because I'm an evil, maniacal teacher mean guy.
Ooh.
So for this question, it's actually really not all that bad, right? The area of the whole thing is 1/2 r squared theta, and the area of this triangle, because it's a right triangle, would be nice and easy. Area equals 1/2 r squared. The theta is pi half, just like it was before. The r is 10, so we're looking at area equals 1/2 10 squared times pi halves. And over here, we're going to end up subtracting whatever this is, 1/2 10 squared. And if you want to do all that in your calculator in one big swoop, again, I don't know if I recommend that. If you feel really confident with the calculator, you can certainly get away with it. 0.5 parentheses 10 squared times alpha y equals pi over 2, enter, I got 78.539. That is going to be 1/2 of 10 squared. I can do that in my head. 10 squared is 100. 1/2 of 100 is 50. 78.539 minus 50.
Why does he keep doing it?
What you got?
He keeps going.
Goes out to 100, goes out to
Y'all
100.
get 20.
I try to do another y equals
Oh, I see. Yeah.
alpha y
20.
Yeah, so the best thing to do is do your times like we did here.
Okay. I thought you know.
Because that times will make it know it's a whole new number. Alright, last one. This question is different, right? Instead of wanting this little piece. We want everything but that little piece. Now there's two different ways to go about this, okay? Kind of up to you. Here's the way I think is the easiest, all right? Put this together like Lego pieces. I think we would know how to find this area, and I think that we would know how to find this area, and we just add them together and we get the answer. So if we're trying to find everything but this piece up here, we could do the area of 1/2 r squared theta of this whole piece, and this time maybe plus our area of the triangle, which is 1/2 r squared. We could do a plus this time instead of a minus because we're trying to add this stuff together. And we know that our r is, I kind of go all over it. We know that our r is 3, so a equals 1/2 3 squared and plus 1/2 3 squared. But what is our theta if we want it to be all of this? Is it still just pi halves? No, it's actually 3 pi halves. Right? 3 pi halves.
I did good.
There's 1 pi half, there's another pi half, there's a third pi half. So I would agree 3 pi halves is our theta.
Shut up, redhead.
This should be this much. Please don't spill your drink, class. And this should be this much. And we combine those together. So, should be pretty good. Let's go to our calculator. 0.5 parentheses 3 squared times alpha y equals 3 pi over 2. And I'm just going to keep it going. Plus 0.5 parentheses 3 squared. All of it in the calculator at once. I got that my area is 25.705. Okay with that? All right, so these questions require no new formulas. They just require a little bit of, figuring it out, using a little bit of brain. Now, flip over to the back of this paper for just a second, okay? Because I did see a question on the quiz that we didn't exactly talk about, so I just want to go for 1 second.
That's a pretty good circle.
That is a pretty good circle, isn't it? I appreciate your compliment. All right, so I saw a question on the quiz that looked like this, okay? And then it had a couple of letters. It had A, B, C, D, okay? It said that the radius was, let's say that the radius was 6. I'm just kind of picking a number there for the radius. And it asked you for all different things, right? So it asked you for what is the arc length, AB, which would be this part here. And that wouldn't be very tough. The arc length AB would be S equals R theta, and the R is 6. And the theta for AB is 90, or pi halves. Type that in the calculator, and it tells you, right? So that, I think we could get that for sure, right? It even asked us maybe for what is the area of a sector of this BC region. And I feel like we could have figured that out as well. 1/2 r squared theta, A equals 1/2, the R is 6. And the theta was 20. Well, 20 is a degree. We can't really use degrees, so maybe we have to do 20 times pi over 180 in order to turn it into radians there. And if we type all that in the calculator, 0.5 times 6 squared times alpha y equals inner 20 pi over 180 inner 6.283. Again, I thought we could figure that out. But the whole reason I wanted to bring this up, and talk to you guys about this question. Let me put a 20 back here again. Is because then there was a question that asked for this. And I knew that this had the 90 in there, so we knew that that was going to be pi halves. And I knew that this had the 20 in there, so I knew that that had to be 20 degrees, and we knew how to convert that. But how do we know what the theta is for this section? Because it's not 90 and it's not 20.
180 minus 90 and 20.
Exactly, right? It's our old geometry. We know that a flat line is 180 degrees. And so what would have to be this last little piece here?
170. Wait.
Unlucky because it's not 200,
Oh, shit.
it's 180.
No, no.
So you were on the right track, but just a little rusty. It would be 70 for that last piece.
Wow.
Here's a
You dig it.
little bonus question for you real quick. What type of angles add together to make 180? This is straight out of geometry. Well, two right angles would make that, right? But I'm looking for a word that's like a longer word. It ends with mentary.
Complementary.
Well, there's complementary and there's supplementary.
Documentary.
Do you remember which one is which?
I think it's
Not in history, yo.
It's something.
I think it's supplementary.
It's complementary.
So I know that
Complementary.
well, I guess this is hard.
Complementary is smaller.
Complementary
90.
and supplementary.
180.
Alright, these are supplementary because that's not really that important. But anyways, I saw one of those on the quiz, so I put it on the worksheet.